Hi, I'm Clifton Roosboom, the founder and CTO of PocketLab and the PI on the IES SBIR Phase 1 project that we call Smart Wheels. First, we'll talk about the Smart Wheels car that we now call G-Force and how in 8 months we were able to go from concept to launching the product on Kickstarter. Then we will present the results of our Phase 1 feasibility study. Finally, we will talk about our Phase 2 work plan. Thanks for your consideration.
Hey kids, are you ready to launch it? Loop it, then learn from it?
This is the story of this guy,
I'm Clifton Roosboom,
who partnered with this guy,
My name is Dave Baker.
and their most recent brainchild, this, the G-Force.
Imagine you're a kid again and you're playing with your friends with Hot Wheel cars. But now you have a speedometer on the car. Meanwhile, they're learning core science concepts that'll carry with them for the rest of their lives.
It can actually be really hard to sort of visualize how speed, velocity, and acceleration are being measured. That's one thing that's really great about G-Force is you have this car, you want to start seeing, oh, what happens when I roll this down a ramp? If I crash into something, if I have it go like kind of up and down a half pipe, and you can visualize the data that's coming out of there.
For the kid, it's just play. For the parent, it's like, wow, my kid's learning some great stuff here. They're really important stuff.
I was getting my PhD in mechanical engineering. I had racks of equipment with wires going everywhere, and I thought this could be a problem that would be useful to solve. In August 2021, for Phase 1 R&D, we conducted usability testing with 6 teachers to get feedback on an early prototype of the hardware. We iterated on the hardware and app with the user feedback, and then we conducted a feasibility study with 2 teachers and 4 classes of 8th grade students. Students conducted 2 investigations. 1, students explored speed by creating and analyzing speed versus time graphs. 2, students investigated the relationship between position and velocity by moving the car back and forth. Metrics of student engagement indicated high levels of student interest in the activities. 91% of students reported that they stayed on task. 83% of students reported that they were focused on the activity. 85% of students reported that the PocketLab G-Force was easy to use. Students showed significant improvement on interpreting the example graph in order to describe the object's motion and relative position over time. In addition, teacher interview feedback showed strong support for further research and development of the Smart Wheels project. What G-Force was able to open up for these kids is that those who are at a lower level of math, it was accessible, or at least more accessible. And when science becomes more accessible, it becomes exciting. 100% of students had a higher engagement than normal. Nobody was lost on this. My kids who have IEPs, they engaged at their level. Everybody grew some. In Phase 2, we will build out 10 modules for middle school physical science that build towards increased mastery of the NGSS science and engineering practices and align with the NGSS disciplinary core ideas. We will develop new data visualizations, such as speedometers and other gauges, 3D models of motion, and metrics for potential and kinetic energy to improve understanding of data measurements and physics concepts. Second, we will develop a collaboration and competition platform to enable activities like roller coaster design and testing, crash barrier design and testing. Finally, we will incorporate our Phase 2 findings into the iterative development of a G-Force 2 car. We believe that Phase 1 has shown exciting promise for the Smart Wheels project, but we need Phase 2 funding to build out the platform and measure learning outcomes with a broader set of teachers and students.